Hello friends, today I'll solve a LeetCode medium problem called sum of square numbers. So we are given a non-negative integer c. So we need to check if there exist two integers a and b such that a square plus b square equal to c. So if there exist two integers a and b, then we need to return true, else return false. So let's consider the first example. It's given that c equal to 5. We can see 5 can be represented as 1 square plus 2 square. So we'll return true. Similarly, for 3, we can see it cannot be represented as sum of a square plus b square. So I will return false. So let's understand the first approach. So I have written the pseudocode. It's given that we'll run a for loop from 0 to square root of c. Then for each a, we will compute b, that is c minus a square square root. So if b is an integer, then return true. So if b is an integer, it means we have a square plus b square equal to c. Then return true. If we cannot find any pair, then at the end return false. So the outer loop runs square root of c times, and for each a we are computing b. So this will also take, at the worst case, big O of square root of c. So you can say the time complexity is big O of square root of c into square root of c. So now let's look at a better approach. Let's look at the second approach. So here I have declared two variables, I points to 0 and j points to floor of square root of c. So within the while loop, while I is less than equal to j, I am checking if I square plus j square equal to c. Then I know that I found a pair, so I will return true. Then if I square plus j square is greater than c, then it means I need to move left, that is I need to decrease the value of j by 1. So I am updating j to j minus 1. Else, if I square plus j square is less than c, I am incrementing I. So let's consider c equal to 34. So here initially I will be 0 and j will be floor of square root of 34, that is floor of 5 point something, that is 5. So I square plus j square is less than 34. So I'll increment I to I plus 1. So now new value of I becomes 1 and j remains same, that is 5. Now I'll check 1 square plus 5 square is 26, which is less than 34. So I'll increment I. Now I becomes 2 and j remains same, that is 5. Now I'll check I square plus j square, that is 29, which is less than 34. So I'll increment I to I plus 1. Now I becomes 3 and j remains 5. So I'll check 3 square plus 5 square, that is 34, which is equal to 34. So here I'll return true. Computing square root of c takes big O of square root of c time. Then I'm using a two-pointer approach. In every iteration, either I'm incrementing I or decrementing j. So this step will take big O of square root of c. So in total, the time complexity will be big O of square root of c. So now I will code this approach. I have declared a variable I equal to 0 and j equal to square root of c. So while I is less than equal to j, if I square equal to c minus j square. So I am doing this to avoid the overflow. Then I'll return true. Else if I square is greater than c minus j square, that is I square plus j square is greater than c, I'll decrease j by 1. Else, if I square plus j square is less than c, I'll increase I. At the end, I'll return false. So let's run it for the sample test cases. You can see sample test cases are running fine. Now I'll submit it. So as discussed, the time complexity is big O of square root of c. So now let's look at another approach called Fermat's theorem. So it says a number n can be represented as sum of two squares, that is a square plus b square, for some integers a and b, if and only if prime factor of n, that is of the form 4k plus 3, appears with an even exponent in the prime factorization of n. So let's say n equal to p1 to the power k1, p2 to the power k2, some px to the power kx. So let's say n is the prime factorization of this, where p1, p2, pk, p1, p2, px all are prime, and k1, k2 integer exponent. So it's given if p of I is of the form 4k plus 3, that is 3, 7, 11. So if pi is a prime of this form, then its exponent ki must be even. So let's look at the pseudocode. So first I'm running a for loop from I equal to 2 to square root of c. So here for each I am checking if I is divisible by c. So if I is divisible by c, then I know that I is a prime factor. So here I am counting the power of I in the prime factorization. So I'll declare a count variable. So while I divide c, I'll just increment count, then I'll divide c by I. Then I'll check. So if I mod 4 is 3, that is it is of the form 4k plus 3, and count is odd, then return false. So at the end, I'm checking if the C is of the form 4k plus 3, then I'm returning false, else I'm returning true. So now I'll code the solution. I'll run a for loop int I equal to 0, I less than equal to square root of C. So I'll check if C is divisible by I, then I'll check its exponent in the prime factorization. So I'll initialize count equal to 0. While C is divisible by I, I'll increment the count and I'll update C, that is. Now I'll check if I is of the form 4k plus 3, that is I mod 4 equal to 3, and count is odd, then I'll return false because I is of the form 4k plus 3 and its exponent count is odd in the prime factorization, then I'll return false. So at the end, if C is not of the form 4k plus 3, then I'll return true, else I'll return false. Let's run it for the sample test cases. sorry, here I will start from I equal to 2. So let's run it for the sample test cases. Sample test cases are running fine. Now I will submit it. So you can see it's working as expected. Thank you.